So if we have x squared minus x minus 6 is greater than 0. So this is a quadratic inequality, right? We have a quadratic and we don't have an equation, we now have an inequality. So this is called a quadratic inequality. What we want to do now is we want to factor the quadratic. When we factor the quadratic, we're going to get x minus 3 and an x plus 2 as our factors. Okay, so based on this, we know the product of these two things has to be greater than 0. What does that mean? Our two factors either both positive or they are both negative in order for us to have a positive product, right? Because we're greater than 0. So our two scenarios here are going to be x minus 3 has to be greater than 0. What's that special word connecting them? And this is not an option, this is a must, right? The first factor has to be greater than 0, and the second factor also has to be greater than 0. Does that make sense to everybody? It's not an or scenario. It can't just be one of them greater than 0. They both have to be greater than 0. So then we go ahead and solve this. We would get x is greater than 3 and x is greater than negative 2. Okay, so this is what we're going to talk about now. Because it's not an or scenario, it can't be x is greater than 3 or x is greater than negative 2. The and, don't they have to overlap? So let's see what this looks like. Remember back to chapter 1, we used to do this with the and the ors. So here's 0, here's negative 2, here's 3. So the first one is saying x is greater than 3. That's that red circle, right? With the red arrow. The other one is x is greater than negative 2, which is now an open circle at negative 2 and then the arrow. But remember, for the and, it has to fulfill the red and it has to fulfill the blue. So Aditya, it's not x is greater than negative 2. That would have been an or scenario, right? So for this one, to fulfill the red and the blue, what would it be? David? X is greater. Good. X is greater than 3. Is this our only scenario here that would get us a positive outcome? No, there's a whole nother scenario. So this would work, or, big or in the middle. We can take our two factors, right? We have x minus 3, x plus 2 has to be greater than 0. And what do we realize? They both can be what? Negative. So in this scenario, we would have the negation of x minus 3 is greater than 0, and the negation of x plus 2 is greater than 0, right? Both are factors. Let me move this over so I have a little bit more space. And saying they're both negative. If both factors are negative, then our product will be positive. Yes? All right. Well, to solve this, wouldn't I have to divide by negative 1? And what happens when we divide or multiply by a negative number? The sign flips. So this becomes x minus 3 is less than 0, and x plus 2 is less than 0. We solve, we get x is less than 3 and x is less than negative 2. This is an and between these two, so it has to fulfill both criteria, right? It has to fulfill both. So let's draw our number line and see what this looks like. Here's 0, here's negative 2, here's 3. So we have x is less than 3, so open circle at 3, going to the right. And then we have x is less than -2, open circle at -2, going to the right. Because it's an and between them, we need to know where they overlap. Where do they start overlapping? Matt? At -2. So this ends up becoming x is less than -2. But now I have this solution, x is greater than 3, and I have this solution, x is less than -2. What word goes in the middle of this? Or goes in the middle of this, because it was either they were both positive or they were both negative, right? Doesn't that make sense? So there's an or in the middle. So now our final inequality solution, if we're graphing, is going to look like this. We're greater than -3, or we are less than -2. Is it okay that we're not finding where they overlap? Yes, that's okay. Why? Because it's not an and, it's an or. So now if we're going to write this out, we have to use our solution set, x such that x is less than -2 or x is greater than 3. Close your solution set. Yes?
Could you write like x is greater than 3 or x is less than -2? We have to start with that.
No, that's fine. Okay, are we ready for the shortcut? All right, let's talk about the shortcut now. You're not going to like the shortcut, but I'm telling you, the more you practice with it, the better you'll get at it. All right, I'm going to take the same problem, x squared minus x minus 6 is greater than 0. We're still going to factor our quadratic. So we're going to factor our quadratic, and we're going to get x minus 3 and x plus 2. We need that greater than 0. Because we want the product to be greater than 0, do we agree we need our product to be positive? Because it's greater than 0, we need the product to be positive. All right, so now what we're going to do is we're going to solve these two, x minus 3 and x plus 2 for x, but those are not our answers. Those are just reference numbers for us. So if I were to solve this, I would get a +3 and a -2. Those are not our answers. Those are reference numbers. So now what we're going to do is something called testing our regions. Test the regions. All right, and the way we test our regions is we're going to use those reference numbers. And I'm going to take the smallest reference number. What's the smallest reference number? -2. So we're going to test x is less than -2. Then we're going to test between our two reference numbers. So -2 is less than x, which is less than 3. And then we're going to test larger than our biggest reference number. So x is greater than 3. So you take your smallest reference number, you test smaller than it. Then you test a number between the two reference numbers, and then you test a number that's bigger than the largest reference number. You do not use the reference numbers. Okay, you do not use the reference numbers in these tests. So now we want our outcome when we test to be positive, since we were greater than 0. So I'll show you what I mean here. We need a number that's less than -2. Well, what number is less than -2? -3. Okay, I wouldn't choose a huge number, okay? Pick an easy number. So I would go ahead and choose -3. And then what you do there is you go and you plug in -3 into the parentheses. So this would be -3 minus 3. I don't care what the actual number is, I just care what the sign is. So what's -3 minus 3? -6, right? And then we have a -3 plus 2. What's a -3 plus 2? -1. I only care about the signs. Well, what's a negative times a negative? A positive. Did we want a positive product? Yes, so guess what? This is a winner. All right, now let's check the middle field. I need a number between -2 and 3. Yes, if 0 is an option, that is the number you want to test. Anytime 0 is an option, you want to choose 0 because it's the easiest. So now let's use 0. So we're going to have 0 minus 3. What's 0 minus 3? Isn't that a negative number? And then we're going to have 0 plus 2. Well, what's 0 plus 2? Isn't that positive? What's a negative times a positive? A negative. Do we want a negative product? No, so guess what we do? We reject that middle region. And last but not least, we need to pick a number that's greater than 3. Well, isn't 4 greater than 3? 4 minus 3 is positive, right? 4 plus 2 is positive. A positive times a positive is a positive. Does this work? Yes. Guess what? If the first one works, the last one will also always work, and the middle one will usually cancel out. All right? If the first one works, the last one will always work, and the middle one will usually cancel out. So these are separate, right? They're not all linked together. So this is all linked together, this middle one, but these are separate. So what we do is we put an or between them in our solution set. So this is telling us x such that x is less than -2 or x is greater than 3. Isn't this the same answer we got doing it the other way? The more we practice, the better we'll get. We ready for another one? Okay, first things first. I need to factor. Well, first things first, actually, what I need you to recognize, we have a quadratic and we have an inequality. Anytime you see a quadratic inequality, think test the regions, test the regions, test the regions. Quadratic inequality, test our regions, always. So now I have a quadratic inequality, but currently speaking, can I factor this the way it looks right now? No, what must I do? Yeah. Good. Pull out a GCF of -1, and then we'll have x squared minus 16 is greater than or equal to 0. I'm going to keep that negative there. I'm going to keep that negative there so I can show you what you would do with a negative GCF. In this specific scenario, we could just divide by -1 and then flip the sign, but I want to leave it there to show you what you would do if you had a GCF and you left it there. So now I'm going to go ahead and I'm going to factor, and we're going to have an x plus 4 and an x minus 4, and we're greater than or equal to 0. Do we agree we need our product to be positive? We need our product to be positive. So what are my reference numbers? I heard it. -4 and +4. Our reference numbers are -4 and +4. So now how do I test the regions? I make that number line, right? We make that number line. And furthest to the left, what am I testing? Furthest to the left, what am I testing? Tejas. I'm the smallest number, and we need x to be greater than or less than the smallest number. Less than, but in this scenario, it's going to be less than or equal to. Why in this scenario am I doing the symbol less than or equal to when before I just did less than? Chris? Good, because the original problem is a greater than or equal to, so we're just following through with the sign. But will we ever use that reference number when we're testing? No, we'll always go bigger or smaller. All right, so that's our furthest to the left, what we're testing. Now, what do I test in the middle? What do I test in the middle? Perfect. We're going to test a number in between them. And furthest to the right, what are we testing? Arish? Good. X is greater than or equal to 4. Do we ever choose the reference numbers? No. So let's pick a number that's less than -4. But now keep in mind here, when we have our products, when we're multiplying to figure out negative or positive, what's here? What is this? A negative. Doesn't that have to get multiplied all together? So what I'm going to do so I don't forget, in each of these regions, I'm going to put a negative just to start. Because that negative has to get brought down to be multiplied together. Because it's not just this product, this factor times this factor times this factor times -1. Do I need to re-explain that to anybody? Because this is an important concept right here. Is your hand up or no? Oh, okay. So let's keep going. So we're going to pick a number less than -4. I will choose -5. So then we're going to have -5 plus 4. Isn't that a negative? And then -5 minus 4. Isn't that another negative? 3 negatives. A negative times a negative times a negative. Isn't that a negative? Do we want a negative or do we want a positive? Positive. So what are we doing here? Rejecting this. If we reject the first column, which other column do you think we're going to reject? The last column will also get rejected. We still, yes. I'm sorry? Less is less than -4. Well, we had to test it, right? When x is less than -4, we chose -5. We still have that negative here, which we brought down. So then we'd have basically -1, and then -5 plus 4 is a -1 again. And then -5 minus 4 is a -9. So -1 times -1 times -9, isn't that negative still? That's why we still get a negative, because of that negative in the front. All right, so now let's choose a number between -4 and +4. What's a good number to choose? 0. Let's go ahead and choose 0. So we're going to have 0 plus 4, that is positive. And then 0 minus 4, isn't that negative? So now I have a negative times a positive times a negative. What is that product? Negative times a positive times a negative. It is a positive. Don't we want a positive? So our solution set is going to be this middle section. So we would write x such that -4 is less than or equal to x, which is less than or equal to 4. If I asked you to graph this solution set, should you know how to graph it? Absolutely. What do? We have 0, -4, 4, closed circle and -4, closed circle and +4, and the line connecting them, or line segment connecting them. Yes.
In like the chart, why is the sign flipped for x is less than or equal to -4? And the problem was greater.
So when we test our regions, what you do is you always choose the smaller number, the smallest number, and you test numbers smaller than it. Then you test between the two reference numbers, and you test the number bigger than the biggest number. Always. That's just the way we set it up.
And why is it like -5 plus 4 instead of -4 for the reference?
We chose a number that's less than -5. Less than -4. So I just chose any random number that's less than -4 to test.
Like, why is it +4, not -4? Like,
because it's x plus 4.
Oh, so you did what's in the first.
All right, let's do another one. Goodness. All right, let's do one where we're testing more than 3 regions. Let's do one where we're testing more than 3 regions. So let's say I have x cubed plus 6x squared minus 16x is greater than 0. I know this is another positive one. They won't always be positive, I promise. They won't always be positive. I'll look for one where it's not always positive. Okay, so we need to factor. To start off, what are we doing when we're factoring? Pulling out a GCF of x. So now we have x squared plus 6x minus 16 is greater than or equal to 0. Let's keep going. We're going to have x and then x plus 8, x minus 2 is greater than or equal to 0. So how many reference numbers am I having now? How many reference numbers do I have now? 3. We're going to have 0 as a reference number, -8 as a reference number, +2 as a reference number. These are just reference numbers. That's all they are. So now when I set up my little line here, I'm going to pick the numbers for the smallest number. What is our smallest number? David? -8. So I'm going to test x is less than -8. Now I'm going to test the region between the two smallest numbers. So what's the region between the two smallest numbers? Between -8 and 0. So where -8 is less than x, which is less than 0. You may. Now I'm going to test another region. What region do you think I'm going to test now? So we did less than -8. We did between -8 and 0. What do you think I'm going to ask you to test now? Between 0 and 2. So we're 0, less than x, less than 2. And the very last region we'll have to test is what? Right? Greater than 2. You got it. So we're now testing 4 regions. All right, let's go with less than -8. If we're less than -8, can we do -9? Sure. Let's go ahead and test -9. So x is just -9. So isn't that a negative? And then we have -9 plus 8. Isn't that another negative? And then we have -9 minus 2. Isn't that a third negative? 3 negatives multiplied together is what? A negative. Did we want a negative outcome or a positive outcome? Positive. We needed a positive outcome since it's greater than. So guess what? This gets rejected. Now we're going to test between -8 and 0. Someone give me a number that's between -8 and 0. -1. Perfect. -1 is great. So x is just -1. That's a negative. And then we're going to have -1 plus 8, which is a +7. Then we're going to have -1 minus 2, which is another negative. A negative times a positive times a negative is a positive. Is this a winner? Yes, this is a winner. All right, between 0 and 2, is 1 a good choice? Yes. X is 1, that's just positive. Then we're going to have 1 plus 8, which is another positive. Then we're going to have 1 minus 2, which is a negative. This ends up being a negative. So guess what? When you test all 4 of them, either these two will work or, well, if this one gets rejected, then this one will get rejected. If this one works, then this one's going to work. So now let's keep going. We have x is greater than 2. Let's go with 3. So 3 is positive. That's just positive. 3 plus 8 is positive. And 3 minus 2 is positive. 3 positives is a positive. So the way we're going to write our solution set right now, we're going to say x such that, and you're going to write these two down. Negative 8 is less than x, which is less than 0. What word do you think is going to go now? David? It is an or x can be greater than 2. Are we ready to see the graph of this? Are you ready to see the graph? The graph would look like this. So we would have the numbers between 0 and negative 8 or greater than 2. So these are all the numbers that could possibly work to make this a true statement. All right, let's step it up a little bit. Matt? Sure.
So will there ever be like any cases where if one of them is wrong, the other other one is wrong? Like would that ever not be true?
No. For any problem I give you, it will be true.
Okay, so then just to save time, if I find one that's
Yep.
correct, just assume the other.
Absolutely. Yep. All right.
When we're testing them, is it always, will one of them always work?
Well, I'll show you a scenario where it's a no solution. I'm going to show you that. Okay, I was going to step it up a little bit, but I'll first show you a scenario where it's no solution. So let's look at this. Y squared minus 5 is greater than 2y squared plus 5. Okay, so it looks like a quadratic inequality, right? So we're going to say, okay, well, we have to factor. But in order to factor, don't we have to bring everything over to one side? So I'm going to subtract 2y squared and subtract the 5. So then we're going to end up with negative y squared minus 10 is greater than 0. Think of what this is saying right now. Think of what this is saying. When I square something, isn't it always positive? When I square something, or when I square real numbers, let's stick with real numbers. When I square real numbers, doesn't it always have a positive product? But then I'm multiplying it by a -1, which would make it negative. And then I'm subtracting 10 from that, which would make it even more negative. Would this ever be greater than 0? No, this outcome would never be greater than 0. This is a no solution. If you went so far to sit there and try to test your regions and do all that, it should not work. It should not work. But I want you from this point to realize that this is a no solution. I don't want you to be robots. I want you to be able to think.
But what if it was -5 squared, then was it just be 25?
Well, no, because this is -1 times y squared. According to PEMDAS, you always do exponents first and then multiply by the -1. So no matter what, even if this was -5, y was -5, this would be -5 squared, which is a positive 25 times negative 1. Because according to order of operations, you always square before you multiply. All right, are we ready to step it up now? Okay, why am I considering this a step up? I'm considering this a step up because now you have to not only recognize this as a quadratic inequality, which means we have to test the regions, and you have to remember that. But now this is also an absolute value inequality. Do you all remember with absolute value inequalities, if it was less than, it was what word goes with it? Matt? And, very good. And if it was greater than, what word went with it? Or. I'm impressed by you, Matt, for remembering. Okay, so what does this mean? We need to split this up into 2 because it's an absolute value. So we're going to have x squared is less than 16, or, oh, no, it's an and, because it's less than. So, and we flip the sign and negate the number, and x squared is greater than negative 16. We're going to move these over and then do what? Factor. So we have x squared minus 16 is less than 0. So we have x plus 4, x minus 4 is less than 0. I'm just going to work on this left side first, and then I'll go to the right. So this time, finally, what do we want our outcome to be? Not positive, negative. We need our product to be negative. What are my 2 reference numbers? What are the 2 reference numbers? Negative 4 and 4. Can someone set up my number line for me with our regions? What are we testing here? Arish.
So x is less than negative 4, and then negative 4 is less than x is less than 4.
Mm-hmm.
And then x is greater than 4.
You got it. All right, so we need to test x is less than negative 4. I'm going to use negative 5. Negative 5 plus 4 is a negative. Negative 5 minus 4 is also a negative. A negative times a negative is a positive. Do we want a positive product or a negative product? Negative. So what is getting rejected here? The first column and the last column. Let's still check the middle column. Let's still check the middle column to make sure it's not a no solution. So now we're going to have 0. So we'll test 0. 0 plus 4 is positive. 0 minus 4 is negative. A positive times a negative is a negative. All right, now let's go to the right side. So I'm going to bring that x squared over, and we're going to have x squared plus 16 has to be greater than 0. Well, x squared plus 16 is greater than 0. What is that? All real numbers. Is there a number we could substitute in for x that won't work? No, it's always going to work. It will always work. So this is in all real numbers. There is an and between them, but an and between this and this means it has to be satisfied by both. So to satisfy this and to satisfy every real number under the sun, wouldn't it just be this? Yeah, so our solution here is x such that negative 4 is less than x, which is less than 4. Yes.
If you're trying to solve one that satisfies both, why wouldn't you use all real numbers considering that it comes from all?
So this is a very limited, so the and is very exclusive, meaning if all, so this is This is like one group. The all real numbers is another group. Because it's so exclusive, this doesn't have all real numbers. It's like the most finite set. All right, let's do another one. Okay, so right off the bat, I see quadratic inequality. What do I hope more than anything? When you see quadratic inequality, what should you be thinking? Test the regions. Thank you. I want you to be thinking test the regions. But even more than just the quadratic inequality, now I've thrown another curveball in here and I put the absolute value. So now we have to remember absolute value inequality. If it's less than, what word goes with it? And. Remember, less than is and. Greater than is or. And makes it more difficult. All right, so now we're going to split it into two inequalities. Who remembers how we format these inequalities? What's the first inequality that we're going to write down? What's the first inequality we're going to write down? Thanks, Rach. Good. X squared minus 17 is less than 8. I'm going to put the word and in the middle. What's the next inequality I'm writing down? Julia? Greater than what? Negative 8. Perfect. All right, let's go ahead, move these over so we can factor. We're going to get x squared minus 25 is less than 0. Because it's less than, what do we want? A negative product. We need our outcome to be negative. So we're going to have an x plus 5 and x minus 5 is less than 0. Our reference numbers are just negative 5 and positive 5. Who's going to tell me what regions are we testing? What am I labeling our regions with? Navia, thanks.
X is less than negative 5.
Let's hold on to that thought 1 second. Sure. Jason and Chris, you need them both? They're going home? Oh, okay, sure. Okay, bye. You guys aren't going home, they just need you in the main office, so you could just take your stuff since the bell's going to be ringing soon. Okay, so we're x is less than negative 5. What's the middle region, Navia?
Negative 5 is less than x.
Perfect. And the last region?
X is greater than 5.
X is greater than 5. Oops. Okay, so now we're going to test a number. X is less than negative 5. So we'll choose negative 6. Negative 6 plus 5, that's a negative. And then we're going to have negative 6 minus 5 is another negative. And negative times a negative is a positive. The first region rejects, which means what? Aditya. Good. The second one's going to be the winner. We're going to check the second one just to be safe. We're going to choose 0. 0 plus 5 is positive. 0 minus 5 is negative. A positive times a negative is a negative. That's what we needed. So this region's our winner. Am I done with this problem? No, we still have a whole nother side to do. So now we're going to bring that negative 8 over. So we're x squared minus 9 is greater than 0. Factor x plus 3, x minus 3 is greater than 0. Our reference numbers, negative 3 and positive 3. Let's test our regions. X is less than negative 3. Negative 3 is less than x, which is less than 3. And x is greater than 3. This time, do we want our product to be positive or negative? Positive. I will tell you, just to speed up things a little bit, this will be positive and this will be positive and this will reject. Okay, you're going to have to graph to see. Isn't there an and in the middle here? You're going to have to graph to see our final solution set. So our final solution set, stay with me. I'm going to do the first one on top. We are -5 and +5. Open circle, line between them. I'm going to do the bottom. This is -1, -2, -3, -4. 1, 2, 3, 4. All right, so I'm going to do the second one on the bottom. So we're less than -3 and we're greater than +3. We need to know where the black and the blue overlap. Don't they overlap from -5 to -3 right here? And don't they also overlap from -3 to +5 over here? So the way you write this final solution, we make our squiggly brackets, x such that we're going to go to the left. We are -5 is less than x, which is less than -3. Or 3 is less than x, which is less than 5. And that is the solution. Because it could fulfill this yellow part, or it could fulfill this yellow part to make the statement true. If you were to graph this, if I asked you to graph this, your final graph would look like this. It would look like that. Your final graph would look like that. All right, we are done for today. You do have homework. It is in the textbook. I will post it on Classroom. It's going to be a combination of what we did yesterday and what we did today. It's going to be a combination of what we did yesterday and what we did today. On the syllabus, it's just the day 4 homework. On the syllabus, it's just the day 4 homework.